So yesterday I didn't talk about question 14, so I'm going to start showing you the answers, the solutions to question 14. So this question says that our school has two copiers, one which can do a large copying job in 12 minutes, and then the other one can do the same job in 15 minutes, so slightly slower than the first one, which means that let me just start labeling these photocopiers. Let me call them A and B. So photocopier A can finish the job in 15 or 12 minutes. 12 minutes. And then photocopier B does the job in 15 minutes, which means that I can actually split up this whole job. So imagine I have a stack of paper. Imagine I have this big stack of paper over here. These are all A4, and these are going to be photocopied into the machine. And so photocopier A, if it does all of this in 12 minutes, it means that if I split it into every single minute, it should be able to do 1/12 of the whole job. So it can do 1/12 of the photocopying, 1/12 of the job, oops, of the job per minute. And then similarly for photocopier B, it does the whole job in 15 minutes, the same stack of papers, but this time in 1 minute it does slightly less because it finishes the whole job in 15 minutes, which means in 1 minute it is only able to do 1/15 of the job per minute. So that's 1/15 of the job per minute. Now, what if you decide I'm going to switch on both photocopiers at the same time and then see how fast it can do the photocopying job when it's working side by side together? Of course, you may need to give a little bit more to photocopier B photocopier A, because it does the job slightly faster, so that by the time they both finish, it will have, they'll finish at the same time. So you give a little bit more to photocopy A, but we don't need to worry about how much we give to A or how much we give to B. Let's just think of how fast these two photocopiers can work together. So if A can do 1/12 of the job in a minute, and B can do 1/15 of the job per minute, if I add those two together, that same stack, the red stack plus the green stack, this is the red stack, which is 1/12 of the job, and then the green stack is 1/15 of the job. That means if I add them together, it can photocopy 1/12 and 1/15 per minute. So which means that if I combine them together, so together they can photocopy copy 1/12 plus 1/15 of the job per minute. And so let's just go ahead and add those two together, 1/12 and 1/15. So you will need to change the bases. That will be 5/60 plus 4/60. And once you combine them, that becomes 9/60. Let me write that slightly bigger. That's 9/60. And so 9/60, we can actually simplify that to 3/20 of the job. So together they can photo 3/20 of the job per minute. Now, since we're talking about functions and equations, let's go ahead and set up an equation to see, how many jobs it can finish per minute. So we're gonna let x be the minutes photocopied, the number of minutes past photocopying. And so our function will be y will be the number of jobs, y be the number of jobs. And so we have a function of y is equal to 320x. That's it. 3/20th x. And so in each minute, it can photo 3/20th of a job. And so that will be the number of jobs that it can take. And so in order to find out what x is, the number of minutes it would take to complete one job, I'm going to put in 1 into the equation. So 1, so let y be 1 job. And so for one large job, 1 is equal to 3/20th of x. And so once I move the 20 and the 3 to the other side by cross multiplication, 20 goes to the top and 3 goes to the bottom. Now we have 20 over 3 is equal to x, the number of minutes takes a photocopy. And so now 20, let's divide it by 3. You can use your calculator or you can calculate it by hand. We'll find out that 20 divided by 3 is 6.66 repeating decimal minutes. And so in the end, it takes 6.66 minutes. Minutes to finish the job if you combine both photocopier A and B together. So that was question 14 from yesterday. Hopefully it's sort of you understand how to do this now. I know it's a little bit complicated. Now let's move on. I said I was going to start chapter 13, the next chapter of our study, which is Introduction to Probability. So today we're going to start talking about probability. In probability, let me just go through what we need to understand in probabilities. Now, in probability, we have some vocabulary that we need to understand first. So, first of all, we have something called an event. And so what is the meaning of an event? An event is a collection of different outcomes. Now, throughout this lesson, maybe I would use a similar example just to make sure we understand what I'm talking about. So for the very simple example, I'm going to talk about in a bag, I have 3 blue marbles. Let me use blue for this. I have 3 blue marbles and 5 green marbles. Do I have enough space? Just enough space. And 5 green marbles. So let me just quickly sketch that out. So in this bag, I have 3 blue marbles, 1, 2, and 3, and then I also have 5 green marbles, 1, 2, 3, 4, and 5. So 3 blue and 5 green marbles. So let's just say it's an opaque bag so that I don't see what is inside. And so what is an event? Event is a collection of different outcomes. So for example, what can be an event? Me picking, so for example, picking a blue marble, that can be an event. Or I can picking a green marble, picking a green marble, that is also an event. I can also have a different event. I can say picking 2 blue marbles. That is also an event. Me reaching in and grabbing 2 marbles, picking 2 blue marbles, those are called events. I can also have picking 1 blue and 1 green marble. These are all different events. I can even go ahead and say something that sounds very ridiculous. Picking a red marble. That is also an event. Actually, it is an event, but whether it happens or not depends on our condition, depends on the situation as well. That is an event. Maybe in a different bag, I have red marbles, but then in this bag, I don't have any red marbles, right? And so these are called events. Now that we know what an event is, I want us to understand the meaning of outcomes. Now, outcome is a specific um, possible result. So when you perform an action, or something, an experiment, um, possible results. So possible outcomes are possible results from an experiment, an or from an experiment, or yeah. So let's just say me picking marbles from a bag is called an experiment, from an experiment. And so the event is the list of all, is a collection of all the different outcomes. Okay, so such as me listing out all those different events. So now that we talked about event and outcomes, I want to talk about something called favorable outcome. Favorable outcome is something that we will look at a lot, that is very important in probability. So favorable outcome. Favorable outcomes means it is the one that you specify, something that you want, that you're interested in. So favorable outcome is an event, or it is a one specified an event that you specify. So for example, if I'm looking for a blue marble, then me picking a blue marble will be the favorable outcome. That will be my, the thing that I'm looking for. So let me just quickly write down, i.e., if I am looking for a blue marble, then picking a blue marble is the favorable outcome. So hope you understand what that means. Let's go straight into an example using the three marbles and the five green marbles, three blue marbles and the five green marbles. So in my example over here, hopefully I would have enough space and I won't be too small. So over here, example, let's go straight into example so that we understand what is going on. Example 1. So let's say we want to find the probability of randomly choosing a blue marble from the bag of marbles. So in example 1, we want to find the probability that a blue marble is picked if randomly chosen. If randomly chosen. Now, I forgot to say the most important thing. How do I find a probability of an event happening? So I forgot to list out to say the most important part, which was the probability of an event. So the probability of an event happening, Okay, so the probability of an event happening is the likelihood, whoops, I think I spelled it wrong. The likelihood, is that correct? Likelihood, yeah, that the event happens or will occur. Happens or will occur. It is the likelihood that the event happens. So how likely is that event going to happen? So for example, if I look at my event here, there are more green marbles than blue marbles. So if I think about it logically, the probability or the likelihood of me picking green marble would be higher than me picking a blue marble. Now, if I look at this bag over here, there are no red marbles, right? There are no red marbles. There is an event called picking a red marble, but is the likelihood of that happening, is it possible for me to pick a red marble from this bag? It's not possible. It's zero. There's zero probability because there is no red marble in this bag, but it is still an event. So the probability is given by a formula. So probability, let me use two lines to write this down, maybe in the middle as well. The probability, and so we use P of the event in a bracket. So this means probability, and the event is probability of the event happening. And we use this notation, P bracket event is equal to, and we want to look at the number of favorable outcomes, And what is the meaning of number of favorable outcomes? So for example, in my bag over here, I have 3 blue marbles and 5 green marbles. And so favorable outcome, if I'm looking for blue marbles, there are 3 blue marbles. That's 3 favorable outcomes. If I'm looking for green marbles, that's 5 favorable outcomes because it's 5 green marbles. And then the bottom is the total possible outcomes. The total number of outcomes. So number of favorable outcomes over the total number of outcomes. So that is the probability of an event happening. The number of favorable outcomes, and the favorable outcome is the one that you specify in the event, and then the total number of outcomes is all the possible outcomes at the bottom. So let's look at example 1. Find the probability that a blue marble is picked if randomly chosen. So the probability, we would write P bracket of, we want the blue marble to be picked. So I would write down probability of blue, okay, that's P bracket blue, is equal to how many blue marbles are in my bag. There's 3 blue marbles. So I'm going to write down 3 over here. That's 3 blue marbles. And then what is the total number of marbles? And so there's 3 blue marbles and 5 green marbles. So altogether there are 8 marbles. So I write 3 over 8. And so remember, the top is the number of favorable outcomes. The 3 blue marbles, that's the one that we want. And then at the bottom, that's the total number of marbles. Total number of marbles. Okay. Whoops, I ran out of space. So total number of marbles over here. So that is how we find probability. And so we can express probability as a fraction or a decimal or a percentage. So in probability, we can express probability as a fraction, decimal, or percent. let me just write percent over here. Percent. And so, for example, if we're looking at example 1, the probability of blue happening will be 3 over 8. So i.e., so we can write down 3 over 8 as a fraction, or we can write it as a decimal, which will be 0.375, or we can write it as a percent, which is 37.5%. So, as you can see, these probabilities can only be between 0 and 1. So let me just say one more time, all probability are between 0 and 1. 0 being impossible. So no chance of happening at all. So no chance of happening. 2, 1, which is definitely happening. Definitely happening. Happening. That means is will happen no matter what. So 1 is 1, well, it must happen for certain. 100% certain. That's why when people say 100% certain, that's the same as 100% probability. That is 1. And so this is a spectrum of our probability. And then somewhere in the middle, we have half, and that means 50% of happening, 50% of not happening. There's also different types, 3/8. We can have a quarter, we can have 25%, which is a quarter, 10% of happening, and so on. Is it possible for us to have a probability that is bigger than 1? It doesn't make sense. No. And so there is no such thing as a probability that is bigger than 1, because you cannot be more than 100% certain. It's either you're 100% certain or you're less than 100% certain, or you're 0% certain. So for example, let's look at the above example very quick. Let's go back up to the bag of 3 blue marbles and green marbles. The probability of me picking a red marble is impossible, so we would say that is 0. And how do we actually write that? So let me just quickly write down this question over here. So the probability of choosing a red marble, so we would write down P of red, so that's the probability of getting a red marble. And how many favorable outcomes are there? How many favorable outcomes? There are 0 red marbles in the bag, and so that's going to be 0 over 8 marbles, and that's 0 red marbles, and so that will result in 0. So that is impossible. Now, how do we get a probability that is 100%? Now, let's just say, for a very quick example, I have a bag, let's just say, I can have another event. So the probability, oops, I keep spelling it wrong. Probability of choosing either a blue or green marble. A blue or green marble. I don't care whether it's blue or green, as long as it's blue or green. And I'm just going to pick at random over there. And so how do I find that? What is the favorable outcomes in the bag? So the probability, we would write it usually as P of blue or green. Now I would go into more specifics of 2 different conditions, but just for now, let's just think simple. For now, let's think simple. How many marbles are blue or green, either blue or green. So that's 1, 2, 3, 4, 5, 6, 7, 8. That's all 8 of them, because there's 3 blue and 5 green marbles, and we're concerned of either of them. We don't mind either of them. So how many favorable outcomes are there? There are 8 favorable outcomes. That's going to be equal to 8 over 8. That's 8 blue or green marbles over 8 marbles. And so that's the probability of 1, or 100%. So this is just a quick introduction for probability. Now I know this video is longer than usual. I'm going to end our lesson over here. We will do more practices next lesson. I'm sorry for the long lesson.